What's up, young mathematicians? Thank you for stopping by here at Tau2Pi. I am Caesar the Tutor, and today we're going to be talking about functions. What is a function? We will be breaking down the definition of a function. We would also be looking at a couple of examples with their graphs, and then we're going to be looking at ways to figure out how to tell if a graph is a function. So let's get started. So what is a function again? Let's take a look at the function definition from a textbook. Let A and B be two non-empty sets. A function from A to B is a rule of correspondence that assigns to each element in A exactly one element in B. So let's take a look at what that means. We have two sets A and B, and they have to be non-empty. So they have to have some elements in them. And a function is a rule that is going to assign a correspondence from here to here. And the things that we know are that one of this cannot go to two of these. It has to be exactly one. And whatever you have in this case always has to go to something over here. So that's also the thing. And finally, we also know that two of these could in fact go to the same one. Okay? And we're going to see some examples of how that happens. So let's take a look at some functions. But the main thing is this definition is kind of confusing. So I'd rather say that a function is a relation that assigns to each input exactly one output. So each input has exactly one output. There are no more than one output per input. So let's take a look at examples of that. We know, for example, f of x equals x plus 3. Now, if you're not familiar with the notation, or if you forgot, f is simply the function name. The name of the function is f. X is the input. This is what we're going to be using to, do our function, and this is the definition. In this case, if I were to give x a value, say x is 5, so I would say f, and I want to input a 5. What I'm letting it know is I want to put a 5 wherever I see an x. So this is just going to be 5 plus 3, which is 8. Now, we know this is a function because it's a line. So, and we know that lines, when they're graphed, are functions. X plus 3 is a line that goes like that. It crosses at 3. So we know that. And that makes sense. It gives me one input, one output. We're good. Now, what about the case where we have two different inputs going to one output? Well, we actually know an example of that. Let's call this function g of x. And we can call it x squared. Now, in this case, I can give g 1, and it's going to give me 1. But I can also give g negative 1, and I would also get 1 back. That's because 1 squared is 1, and negative 1 squared is also 1. And like I said, this makes sense to us because we know the graph. And let me label these. This is the graph of f of x equals x plus 3. And this right here is going to be the graph of g of x equals x squared. And so we know that when we graph it, this y right here matches with this x. But this y over here matches with this x as well. And we're fine with that. That's good. Remember, one way of testing these once you have the graph is to do the vertical line test. The vertical line test will tell you if you have a function. In this case, when we do a vertical line, we touch only one point. When we do a vertical line, so we're never going to touch more than one point with our vertical line. And the same thing in this case. If we do a vertical line, we will never touch more than one point. So that gives a good indication that our function, or that our graph, is really a function. And so now we can take a look at other graphs I mean, we'll review them, but let's take a look at other graphs that are not functions. You have a circle. The circle's the equation of the circle is x squared plus y squared equals, well, in this case, let's call this 5. So this is 25. But, so it's a radius of 5. But, same thing, when you take the vertical line, you're going to see that we run into problems. Therefore, a circle is not a function. And finally, to give these sets their proper names, we're going to call them something different now. We're going to call this one the domain. We're going to call this one the range. And the domain becomes the set of all the values that are allowed into our function. And the range becomes the set of all the values that come out based on all our inputs, based on our domain. That is all for today. If you like the video, make sure you hit the like button. If you want to see more content like this, make sure you hit the subscribe button. I will be posting daily videos ranging from 3rd grade mathematics all the way to 12th grade calculus A, B, and BC. So make sure you stay tuned for more. If you have any questions, comments, concerns, emotional outbursts, make sure you drop them in the comments below. Thank you for stopping by. See you later.